Okay, good morning to everybody and welcome to our first technical webinar. I'm Stefano Corradi and I'm part of the LAUMAS sales department. Today I will introduce you our webinar that will be about our multi-channel weight transmitter, and it will be shown to you by my colleague Mr. Davide Vescovi. Just few rules. Today your camera and your microphone will be switched off, and the only way to be in contact with us it will be via the chat that you can find on the left of your laptop, and you can make questions also during the presentation, but then they will be answered at the end. So this morning we will have about 30-35 minutes of presentation and then 20-25 minutes of question time at the end. So don't worry, you can make also the question during the presentation. I will help them and then we will answer to you at the end. I just want to remember that the webinar will be registered, so within 10 days it will be also available on our website, where you can find it and look it again with also the question and the answers, or also to use it for your customer or your other colleagues. I want to remember to you also that at the end of the webinar you will get also an email from us with inside a survey that we kindly ask you to fulfill it and send it back to us in order to improve our new future webinars and to understand what goes well and what goes wrong. Okay, now I give the word to my colleague Davide that will start with the webinar. Thank you.
Okay, hello everybody. My name is Davide Vescovi. I'm with the R&D department of LAUMAS Elettronica, and I am also responsible for metrology and product certifications. So today I will talk about LAUMAS multi-channel devices, and since we would like to show you all the major features of these devices, we found out it was quite difficult to do it live. So we have recorded some videos in the last few weeks, and now we will show them to you. So here an outline of the webinar. We will start with the videos, 4 videos about wiring, calibration, equalization, and diagnostics. During the video, I kindly ask you not to move forward and backwards or try to pause and stop the video. If you don't do that, the video will be controlled by us and will all be synchronized together. So after the videos, we will have a live part of the webinars. I will show you how to read the raw count from the ADC via Modbus, and then we will have questions and hopefully answers. Okay, in all the videos that you will see, the setup will be a multi-channel transmitter, a TLM8, connected to a 6-load cell platform. So a couple of words about the TLM8. It has got 8 independent channels for load cells. It has an RS485 and an analog output, and optionally it may have a field bus. One from the field bus is listed bottom right. So we have almost all of them, almost all the field buses on the market, ranging from Profibus to Profinet to EtherCAT, PowerLink, Ethernet IP, and so on. Almost everything on the market. It can be mounted rear panel on a DIN rail, or it can be put into an ABS box with an IP 67 degree of protection. What are the main advantages? They come from the fact that in multi-channel devices, every channel is separately converted into digital by the microcontroller, and then the total weight is calculated by the device's firmware. This makes more information available with respect to traditional analog systems, and makes it possible to have single-channel diagnostics. So if there's a fault, you know immediately which load cell has generated it without making tests. You can have the load distribution display and digital equalization, but we will see all of this function better in the videos. Other features of multi-channel devices, they are all approved according to European Directive 2014-31 UE, so also the technical standard EN 45501 and UML 76, so they can be legal for trade. All these devices can be connected to one of our W series indicators. In this way, all the multi-channel specific functions, the ones we have just seen, so diagnostics, equalization, and so on, can be controlled by the indicator. So everything works just as if the load cells were directly connected to the indicator. Okay, now let's start with the videos. The first one is about wiring. It is a quick note about how to wire the load cells, because you have to put more than one wire in the same terminal and select only one of the reference signals. Okay, let's see the video.
Hello, I will now give you some hints about how to wire a LAUMAS multi-channel transmitter, because we know it can sometimes be a little bit tricky because we have a lot of wires and you have some terminals to share. Here we have a TLM8. You can connect up to 8 load cells, but in this example we have 6 of them. There are of course a sig- sig+ pair for each load cell, 4 in the top row and 4 in the bottom row. The terminal positions are the same in the 2 rows. For example, terminal 1 is sig- for load cell 1. Terminal 14 is sig- for load cell 5. Then we have an excitation pair, excitation minus, excitation plus, every 2 load cells. So 2 adjacent load cells have to share the supply wires, and you need to put 2 wires in each terminal. Here, as you can see, we have 2 excitation minus wires, 2 black wires, going to terminal 3, and 2 excitation plus wires, red wires, going to terminal 4. Then we have the reference signals. There is only one ref minus terminal and one ref plus terminal. So for 6 wire load cells, you basically have 2 choices. The first solution is using an external auxiliary terminal to parallel all the ref plus and all the ref minus, and then connect it to the ref plus and ref minus terminals of the device. This basically makes an average of all the ref signals. Alternately, we have a second solution. You may connect only one ref plus and one ref minus, coming from a load cell at an average distance from the device. If you have a significant difference in the cable length among the load cells, don't pick the longest, don't pick the shortest, pick one in the middle. This is again similar to making an average. Please remember to insulate the unused ref signals. For 4-wire load cells, just short the ref minus terminal to one of the excitation minus terminals, and the ref plus to one of the excitation plus terminal. In this example, I've got 6-wire load cells, and I have implemented the second solution. Only these load cells give the reference. The brown wire is the ref minus and goes to terminal 7. The blue wire is the ref plus and goes to terminal 20. And I insulated all the remaining ref signals.
Okay, the second video is about calibration. Please take into account that what I will say can be applied to any other LAUMAS device, not only multi-channel ones. Okay, let's go.
Hello, I will now show you how to calibrate a LAUMAS device. In this example, we will use a TLM8, a multi-channel transmitter, but what I'm going to say can be applied to any other LAUMAS device. We will first start with what we call theoretical calibration, which is basically entering into the device nominal values for load cells and system. Before we start, a quick technical note about the word calibration. We use it for traditional reasons, even if it is not very suitable, because it has a well-defined metrological meaning, which is related to measurements and not to changing devices parameters. The right word here would be adjustment. Okay, entering the menu with Enter plus ESC, we get Calib. Enter, and we see FSTO, which is the total capacity of the system. If you have more than one load cell, you have to put here the sum of the capacities of the load cells. In this case, we have a total capacity of 80 kilograms, so I will type here 80. The next parameter is sensib, which stands for the load cell's sensitivity. Here we have different cases. If you know the measured real load cell sensitivity, you can put it here. If you have more than one load cell, type here the average of the sensitivities. In many LAUMAS load cells, you have a label with the measured sensitivity, and you may also find it on the test certificate coming with every cell. If you don't know the measured sensitivity, type here the nominal value, or the average of the nominal values if you have more than one load cell. In this case, I don't know the measured sensitivities, but I know that all the load cells are 2 mV over volt ones, so I will leave here 2, the default value. Next is DVIS, which is the system's resolution, the minimum weight variation you want to appreciate. The device automatically proposes a value which gives you around 10,000 total divisions. We will keep it. Okay, now the theoretical calibration is over, and we start what we call the real calibration, that involves having sample masses and operate on the real load receptor. If you have a multi-channel device and you want to do a digital equalization, this is the moment to do it, before the real calibration. There is a dedicated video about equalization. Let's start the real calibration. The first thing to do is to perform a zero. So unload the platform and press enter. You will see the weight value sensed by the device. Press enter again and you will get 0. Enter again to go on. Now you see imp0, which is a very special menu, and I will not talk about it today, because you normally do not have to use it. The next important menu is weight. This is the weight correction menu. In some cases you could avoid it, but the accuracy you will get will be quite low, in the order of some %. So you normally should do it. Put a known sample mass on the scale. The closer the value to the system's capacity, the better. In this case, I will use 40 kilograms, which is 1/2 of the system's capacity. 1/2 of the system capacity is the minimum weight we recommend for real calibration. Let's do it. Okay, press enter, you see 42 dot something, but we know it must be 40, and so we correct it. Enter, enter again, and back to the weight. Okay, it's done. The system is calibrated.
Okay, before we start the video about equalization, a note about the last video about calibration. You can repeat the last procedure we have seen, what we call the real calibration, the weight correction using the weight menu, up to 5 times. This allows to perform a linearization. This is not normally needed because the system should be linear already, but you can use it in case of mechanical problems or if you need an extra accuracy. Okay, now the next video is about equalization. This is a potentially really big advantage for some kinds of installation of multi-channel transmitter. Let's see it.
Hello, I will now talk about digital equalization in LAUMAS multi-channel devices. Here we have a TLM8 connected to 6 load cells. In this video I assume that the theoretical calibration has already been done, so we will see a rough weight value on the display. There is a dedicated video about calibration. Because of the differences among the load cell sensitivities, in normal analog system you get a different weight while moving a sample weight around on the platform. Let's see it. If I put the weight here, I get 6.21. If I put it here, I get 6.38. And if I put it here, I get 6.44. In traditional analog system, if you want to solve this problem, you have to use a junction box with trimmers, and you often have to do more than one trip around the platform, which can be very expensive and painful in case of a system with big capacities like wave bridges. With LAUMAS digital equalization, the equalization is a calculation done by the microcontroller, and you always have to do only one trip around the platform. But let's now see a practical example. Here we have a quite extreme case because we mixed up load cells with different capacities. 4 10 kilogram load cells and 2 20 kilogram load cells. This is not at all recommended, but you will see that the system is able to cope even with this situation. For this kind of equalization, use a sample weight at least half of the load cell capacity. In this case, I will use 5 kilograms. Okay, go to the menu item Equal inside Calib, press Enter. You see EQREA, which stands for Real Equalization. That's what we want to do. That is an equalization with a sample mass. So press Enter. You see equal 0, which is the system 0. Unload the scale, wait for stability and push Enter. You now see equal 1. Place the mass on whichever load cell you want. Wait for stability and press Enter. Now you see equal 2. Move the mass to the next load cell. Wait for stability and press Enter, and so on. It says valid, so the equalization was successful. Now the weight value is the same all around the platform. Let's check it. Let's go back to the weight. Okay, if I put the weight here, I see 3.23. If I put the weight there, I see 3.23. And if I put the weight there, I see 3.23. So the weight value is the same all around the platform, with only one equalization trip around it. Please note that we see 3.23 and not 5, because we have not done yet a real weight calibration.
Okay, now the last video, which is about diagnostics. Since in a multi-channel device, every single channel is separately converted into digital, there is more information available than in standard analog systems, and this allows to have stronger diagnostics. Let's see it.
In multi-channel devices, every single channel is separately converted into digital by the microcontroller, and the total weight is calculated by software. This makes more information available with respect to traditional analog systems. At startup, the system automatically detects the connected load cell. You can also trigger the auto detect with the menu item cell channel inside the menu Calib. I press enter. It is now checking the channels. Now it says Auto 6 because it detected 6 connected load cells. If you press enter now, you will save the current selection and make it permanent. This has got an advantage. If a load cell breaks down while the system is off, you will get an error message at the next startup. With the auto detect, you will not, because the system discards the channels that are not good at startup. So I press enter to save the current selection, and I go back to the weight. Now I show you that if I disconnect one of the wires of one load cell, I will get an error. Let's see it. Okay, you see R cell 4. So you know which load cell has generated the error. Okay, now I put the wire back. And the error has gone. You can easily visualize the load distribution among the channels with the key test. You can see that the weight is quite equally distributed. Here you have the channels from 1 to 6, then 7 and 8 are off, and for each channel you have the percentage of load. If I put a weight on the platform, you can see that the distribution changes. Let's see it. You see that the load cell distribution is changing, and load cell 5 is now the most loaded one. Okay, I remove the weight and go back to the weight. Then you have some more advanced diagnostic features. There is a dedicated menu called Diag. here you are. I will show you an example. If I set auth 0 to yes, I enable diagnostic on 0. So when I set the weight to 0, the system stores the weight distribution. If the weight goes to 0 again with a different weight distribution, I will get an error. To simulate it, I will now put a mass in a certain position. And do a calibration 0. Enter. The system asks if I want to save this weight distribution. I select yes and confirm it, enter. Then enter again, back to the weight. Then I add another mass to move the weight away from 0. And then I remove the first one. I will see 0 again, but I will get an error diag, because the system senses that the weight distribution has changed. This might reveal mechanical errors on the system. The same alarm system can apply to load values different from 0, but it works only with systems where the load distribution in the container is repeatable, for example liquids, and you want to monitor that this distribution stays always the same, because if it changes, it can mean that there are problems. The last thing I want to show you is the event logger. The device stores the last 50 events that happened to the system, including errors on the weight, calibration and equalizations done, with additional information. This can be very useful if you get an error and you don't understand where it has come from. Let's see. There is a menu item called Event. And with this EV, you can see the log. For example, here we see that the last event was a diagnostics error.
Are over, and we go on with the live part of the webinar. I will show you how to read single channel row counts from the ADC via Modbus. So now I will stop the presentation. I will try to share my desktop. Okay, now it should arrive. Okay, now we should have it. I advise you to press the effective dimensions button to see everything better. So on TLM8 you can see only one calibrated weight value on the display, but if you use a Modbus or another field bus, you can read the row count coming from the ADC for every single channel. They are basically the millivolt values converting into digital. So they are 24 bits values, unfiltered, not equalized, and not calibrated. So really raw values. Here I have the same setup that we have used for the videos. So there is a telemate connected to the usual 6-slot cell platform. I have connected the telemate via RS485 to my laptop using a USB to RS485 converter. And I'm using a software called Modbus Pol, which can also be tried for free if you are interested in it. And this acts as a Modbus master, whereas the telemate is a Modbus slave. So I'm asking query to the telemate and getting answers. I have already set it up to read the exchange register, which contains the raw counts, which are Modbus holding registers with addresses from 40,051 to 40,058. You have it in the window in the middle of the screen. And so at startup, this feature is disabled, so you read all zeros everywhere. To enable it, you have to send a command to the command register, which I have prepared here. So if I now send the command 24 to the command register, I will enable the first mode. These features can be used in 3 different modes. This is the first one, which is the 8-channel low resolution mode. So in this way, we can see all the channels at the same time, but in low resolution. So every channel takes 1 Modbus register, so 2 bytes, 16 bits. To do that, we have discarded the 8 least significant bits. This way, we can see all the channels at the same time. So here we see the ADC values for channels from 1 to 6. Then channels 7 and 8 are off, and so we see conventional values. If we put a weight on the platform, now Stefano will do it, you will see that the count changes. Okay, you see, for example, now channel 1 has raised a lot. Okay, if I now send the command 25 to the command register, no, sorry, we will switch to the high resolution mode for the first 4 channels. So now we see only 4 channels from 1 to 4, but every channel is in its full 24-bit resolution. And now every channel takes 2 Modbus registers. So in total 32 bits. In this case, the 8 most significant bits are not used because the values are 24 bits 1. So here we have the channels from 1 to 4. If we send the command 26 to the command register, we keep the same mode, but for the channels from 5 to 8. So again, high resolution mode, 2 Modbus registers for each channel, for channels from 5 to 8. If I now send 27 to the command register, I will disable the function, and we will see all 0 everywhere again. Okay, that's it. We are done. So I think we can move to question time.
Okay, thank you, Davide, for your presentation. I hope we have been clear. And we already got the first question from Mr. Simone that is asking if there is an EPROM memory on our multi-channel transmitter, so when the power is shut down device.
Yes, we have an EPROM memory, even if it is not used for the shutdown of power supply. not okay. It stores the important values, so you will keep them through a power cutoff. If this is the question, yes.
Yeah, I think it means to, if everything remain on the multi-channel transmitter and when the power shut down, and you don't need to do everything again, like calibration and stuff like that. Mr. Grivos is asking if the diagnostic is available on any field bus.
Well, it is, but not completely. In fact, in field buses, you have a status register when you can see if there's an error. But in the status register, you don't know, for example, which load cell has generated the error. But you can use the mode we have just seen to read the raw count. And in this way, if there's a problem on a load cell, you will see strange values. So you have a way to look at the single load cells and know which one has generated the error.
Very good, thank you again, Davide. Now we can wait, maybe if there are other questions. And just remember that maybe Mr. Fernando Costa asked if these videos will be available. Okay, yeah, within 10 days you will find the recorded webinar complete on our website, but also if you need the single videos for maybe technical assistance or to make also training to your techniques, we can forward them to you, no problem. You just send us an email and we will send it to you, all the videos about calibration, equalization, and stuff like all the other videos. Okay, Mr. Maxim Bolger is asking if we can use the TLM8 instead of junction boxes. Yes, of course. We as you saw, or maybe who of you followed also our last webinar last week about the always multi-channel transmitter, but it was commercial webinar. We have the CLM8, TLM8, and TLB4. They can be used as junction boxes because, you know, instead to have a millivolt signal that goes from the load cell to the panel or to the PLC that is maybe far away, and the millivolt signal is maybe a low signal that can be disturbed by other signals. You can go directly from the load cell to the panel to the PLC with a strong signal that can be in analog output or any kind of field buses. So yes, you can use it. As you maybe saw on the presentation, the TLM8, we said that it can be mounted in an Omega DN rail, so in the rear panel, or also directly in the field inside ABS box, with also with an external keyboard. While the CLM8 can be installed inside a IBS box also, or a stainless steel box, while the TLB4 can be installed or in an Omega DN rail bar again, or in a front panel mode. Yeah, we got another question. Mr. Gravazzi said if we can use a different load cell with different signal outputs or capacities and equalize the system in any case like that.
Yes, you might. In fact, in the video about equalization, we did that before we mixed up load cells with different capacities, 10 kilogram load cells and 20 kilogram load cells. So even if it is not very normal or recommended, we can solve the problem even in these extreme cases. Not only to solve small differences between sensitivities, but also for big differences among the load cells.
Okay, thank you, Davide. We got another question from Mr. Rogers that is asking if we have some simple monitoring software available in case that we want to monitor the load cell from of the site, so from our office.
Well, not at the moment, no, not real software. You should do that in the you should do software on your PLC. If the distances are not too big, you might use the solution which involves one of our W series indicators connected to the multi-channel device via RS485. In this case, the transmitter can be on the field, and for example, the indicator can be in a room, in a control room, and you have all the information you would have on the transmitter, on the indicator, so in a more comfortable situation for humans.
Yes, exactly. For that reason also was the question of Mr. Maxim Bolger, that for example, our CLM8, we studied it like a intelligent junction box for especially for way bridges, because for example you can connect the 8 load cell to the CLM8, put the CLM8 inside the hole where under the way bridge, then from the CLM8 to our W series indicator for example our WT-BGE, you have all the information that you have on the CLM8 also on our indicator, so you can monitor the load cell, you get the repartition of the weight, you get the equalization, you get the errors or the diagnostic, and also is it possible because the metrological approval of our multi-channel transmitter is from their own, so standalone, or together as system with one of our W series indicator. So the main indicator became the W tab or the W Inox or any kind of our W series indicator. I don't remember, Davide, if you already tell to our follower if there are some ethics approval for our multi-channel transmitter.
Well, not at the moment, but we are working on that. We plan to have 2 versions of the TLM8, one for zone 222 and another one in an exclusion-proof box from zone 121. So we will soon have it. Okay,
very good. I don't know if someone else has some other doubts or question. Okay, Mr. Grevats is asking about if we have the UL approval for the US market or other specific approval also.
Yes, we have it. All the multi-channel products except the CLM8 have it.
Okay, so just to be more clear, the UL approval is a specific approval for the USA market and also in Canada. We got also for our TLB4 the approval, the NMI approval for the Australian market and the New Zealand market. So I don't know if someone of our followers here are from that country, those countries, or work with those countries. But anyway, we got also that approvals. And we are going, if I'm not wrong, Davide, also to get it for our W series indicator. Okay, I don't know, someone else has questions, or do you want some clarification in something specific? We still have about 10, 20, 12 minutes available. In the meantime, I remember you that, again, the webinar will be available on our website, and also you will get at the end of the webinar an email with the survey that we please kindly ask you to fulfill it and send it back to us. Also, for someone of you that didn't follow our last week webinar, commercial webinar about the multi-channel transmitter, where we explain all the three types, so TLB4, TLM8, and CLM8, or their main advantages, the features. You can see it. It will be available also probably within the end of this week, so you can download it also and have a look at it again. Okay, Davide, I don't know. It seems that we have been clear, because nobody has other question. So if it's okay for everybody, we can. Okay. We got a question at the end. So Mr. Tufik is asking, do we need to do theoretical calibration always, or only when it can do the real calibration?
Well, you have to put some starting values for the theoretical calibration, but they can be very rough, and then you can correct it with the real calibration. So just put a starting value, for example, on in the theoretical calibration, and then you will correct it. So don't worry too much about that. Just set the full scale and the division, so the minimum weight variation you want to appreciate, and then you can correct everything with the real calibration, the weight correction. Just wanted to add something about the question about remote monitoring of the devices. In fact, you might also use our TCP/IP models, which are standard Ethernet, let's say. So if you can connect them to an Ethernet network, which has a gateway to the internet, to the external world, you may access their web server. They embed a simple website. And on this, for example, you might also see the load distribution in percentage. So it may help about the situation Mr. Rogers was asking about.
And so, if I'm not wrong, Davide, you can see it with the TCP/IP also, for example, for any kind of PC or laptop, smartphone, or any kind. We got another question from Mr. Jerome. He's asking if the indicator is able to display the millivolt reading of every load cell.
Yes, it is. You have a test menu which allows you to show every single channel millivolt. Yes.
Okay, we got another question from Mr. Juice. He's asking if it is possible to do multi-point real calibration.
Yes, it is. In fact, you simply have to do the procedure I have shown for the real calibration, but you can repeat it up to 5 times. Just don't go back to the weight, not to interrupt the procedure, and repeat it up to 5 times. This is basically a linearization. You normally should not need it, because the system should be linear if it's well done from a mechanical point of view. But you can use it to correct small mechanical problems that you can solve modifying the installation, for example, or sometimes if you need super and extra accuracy.
Very good, David. Okay, we got another question from Mr. Jerome that is saying telemetry indicator seems a good indicator due to the fail-safe features, which allow us to detect faulty load cell. Is this available to other model of your indicator? Yes. As we told you before, all these advantages are available on all our multi-channel transmitters. So TLM8, TLB4, and also CLM8. Also, if you use them as junction box connected to via RS485 to our W series indicator, you can get all these features on also our indicators. So with the W tab or W inox, because they can be a standalone transmitter or are an intelligent junction box. For example, also for silos, you can put the CLM8 as junction box connected to the W100 on your panel, and you get all the advantages also on the indicator in the front panel. Okay, you're welcome. We still have a few minutes for last questions, if there are or not. If anybody has other questions, we can say to you, thank you very much for your time, and thank you for following our webinar. I just want to remember you that we will have other webinars in the next month. For example, in May we will have the new webinar regarding our latest product, LCB, that will be a load cell digitizer, so a very interesting product. There will be, as this time, commercial webinar and then technical webinar. You can follow both of them. You just need to register yourself to both of them, and you will find it on our website in the webinar page. You can register also now, no problem. And I just want you to remember that who of you didn't follow our last webinar about the multi-channel transmitter, the commercial webinar, just go on our website and see it, because it will help you and you with the customer, and all goes. Okay, thank you again. Thank you very much for your time and for following us, and have a good day. Goodbye.